so section 1.3, triangle inequality. Now, the reason it's called the triangle inequality is essentially it's just saying that if we want to go here, the quickest way to get there is straight there, not going through two other spots. That's really what it's saying. And that's why it's, the triangle inequality is that hypotenuse is going to be shorter than the sum of the legs. Okay, so what is the triangle inequality? It just says that the absolute value of Z1, Z2 is less than or equal to the absolute value of Z1 plus the absolute value of Z2. Okay, so you see, if this here is Z1 plus Z2, then this was maybe Z1 and that was Z2, and so it's just saying the length of Z1 plus Z2 is always less than or equal to the sum of the lengths of the original vectors you added. Now for the proof, what we're going to use is actually the squares because they're a little easier to work with. We don't have to deal with square roots of that absolute value. So notice that what we want to show, if we're working with the squares, is that Z1 plus Z2 squared is less than or equal to Z1 squared plus 2 Z1 Z2. Oops, kind of ugly there. I'll put you on pause. I hear my grandson. All righty. So plus Z2 squared. All right, so that's what we're going to need to show. So we'll start with Z1 plus Z2 squared. And the nice part is that we know that that's just Z1 plus Z2 times Z1 plus Z2 conjugate. But that is just Z1 plus Z2 times Z1 conjugate plus Z2 conjugate. So you see, this is where life's getting much better. So, we get, when we multiply this all out, we get a Z1 conjugate plus a Z1 Z2 conjugate plus a Z2 Z1 conjugate plus Z2 conjugate. Okay, now it's nice. This first term and the second term are exactly the terms we need for the first and last are what we need for the first and last there. So this is absolute value Z1 squared, and down here we're going to get the absolute value of Z2 squared, so that's great. Now we just need to work on the middle. Well, this is Z1 Z2 conjugate, and notice then that this here is Z1 Z2 conjugate. How about that? Yeah. See, because then if I take the conjugate of this product here, I'll get the Z1 conjugate and then Z2 conjugate, which is just Z2. So we've got that. So this is Z1 squared plus just a minute here. Okay, so this ends up being 2 times the real part of Z1, Z2 conjugate, and then plus Z2 squared. Okay. And so now these have all been equalities, but then what we know is that this real part of Z1, Z2 conjugate is less than or equal to, so these other things are equalities, but plus 2, it's less than or equal to the absolute value of Z1, Z2 conjugate plus Z2 conjugate squared. So there, because again, the real part is just the x, and but since the magnitude is x squared plus y squared, and then square root, well, so you're adding in that y squared, so the real part has to be no bigger than the absolute value of the whole thing. And now we can separate. So we had that one inequality, but now this is an equality again, in that I've got Z1 absolute value of Z1 times the absolute value of Z2 conjugate plus Z2 squared. But now this is Z1 squared plus 2 Z1 absolute value, but now we get to get rid of that conjugate because we're just talking about the absolute value of Z2 and Z2 conjugate. So we get that, and now that's a perfect square of Z1 plus Z2, those absolute values squared. So this was where we had to get so that we could, see, that's what we were trying to get to, so that we could have that perfect square, and we did. And so the absolute value of Z1 plus Z2 is less than or equal to the absolute value of Z1 plus the absolute value of Z2. So there we go.